everyone. My name is Injeti Rohan. My roll number 19EC01034. In this experiment, we will learn about the convolution and trend removal. In first part, we have to calculate the impulse response of given system. Impulse response is output when input is delta function passed through an LTI system. These are the four impulse responses for the given system. And in a second part, we have to plot the signals given. So we are going to MATLAB. First, we have to load all the four signals and plot the signals. After plotting, we get the graphs. These are the four signals given, and in system 1, this is the impulse response. And after loading all the four signals and convolving using the convolution block, and this is the convolution block. As we know that length of output equal to length of input plus length of impulse response minus 1. After writing convolution function block, we can use it in these four systems, and output of convolution in the system 1, we will find it. And this is the outputs for the four signals. As we see that the trend line here, only low frequency are passed through, so we can say that system 1 is low pass filter, and this is the impulse response. This is the impulse response for system 1. And in second part, it depends on the value of n. It depends on the value of m. We have to give a value of m, and impulse response depends on the value of m. After loading all the four signals and convolving using the convolution function block, we get the output of the convolution in the input signal is, we have to enter the value of ms. Let's take value of ms 50, and this is the output for the four signals. Here we can see that low frequencies are passed, so we can say that this is also a low pass filter, and we will do it for n equal to 50, and this is the impulse response of for m equal to 50, and for m equal to 100, we can see here that low frequencies are passing. This is the low pass filter, and the impulse responses for m equal to 50 is this. Now coming on to the next part, system 3. Similarly, for system 3, the impulse response is 1 minus 1. Output of convolution is, here we can see that only high frequencies passed, so we can say that system 3 is a high pass filter because only high frequencies are passed, and this is the impulse response for system 3. And similar to system 3, now coming to system 4, we run this program. Now coming to the system 4, the impulse response is 1 by 2, 0 and minus 1 by 2. We are loading all the input signals, and output of the convolution is this. Here we can see that only high frequency is passed, so we can say that system 4 is a high pass filter, and this is the impulse response for system 4. And coming to the next part, coming to trend line, we have to let's take the any signal, and we have loaded the signal, and convolving it to an impulse response for a random delta input. Let take n equal to 100 and let take m equal to 100 and here b is the trend line and a is the output after removing trend line from input. So after running this program, here is the further graph. This is the input. You can see that the baseline is increasing and decreasing. After removing the trend line, we got the output as stable. So this is the removal of trend line. Now coming to the next part. Now coming to the next part, we have properties properties of the above discrete systems. System 1 and System 3 and System 4 are memory, causal and stable systems, and System 2 is memory, invertible and causal and stable system. Causal system means output of the system is independent of future values of input, and non-causal system is output of system depends on future values of input of any instant. And a static system means output of system depends only on present values of input, and dynamic system means output of system depends on past or future values of input at any instant of time. Memory system means output depends on past and present input. Stable system produces a bounded output for a bounded input. And System 1 and System 3 and System 4 are memory, causal and stable system. System 2 is memory, invertible, causal and a stable system. Thank you.